Fans. All right. Okay. Hopefully you got your hands wet. You looked at a couple of things. And one of the things that one group had actually is going to lead into what's coming up next. All right, let's go back to started my recording again, right? And I'm going to come back. Then, ay caramba, share screen. Here we go. Next thing we're going to talk about is overriding superclass methods. All right, so I have a method in my superclass, and I'm saying I'm going to override it. Now, we've heard a word similar to this. We've heard overloading. Overloading was when I had the same name, but different signatures, different parameter lists. That was overloading. So I had multiple versions of a method name. Overriding says, hey, that one that's in the superclass, I'm going to override it completely. I'm going to take its name and everything. And as you take a look here, we're going to see that we come up with a set score with the exact same signature in curved activity as there is the set score up in graded activity. So I have another superclass, subclass relationship, but as you see in the UML chart, I am overriding it. No soup for you. When this method gets called on an object from curved activity, it's going to use curved activities set score, not graded activity set score. All right. And again, we use the term signature quite a bit. You should be quite familiar with it. Some of you like this last bullet, the ampersand override annotation. Just it's like making a note to yourself that you're going to do that actual override, something that's optional. A subclass method that's overwritten could still call the superclasses. Not something that we really want to get into, but we can, again, here's the terminology, overload as well as override. You know, that would be a good test question. Overloading versus overriding. Overloading is different signatures. Overriding, you have the same signature. Okay. And there was an example in the textbook, and it was the graded activity and curved activity. And if I switch to the book, you know, here it is again. And you actually typed in code listing 1013, which was called curved activity, and curve activity extended graded activity. And it actually was an example of showing you how to override that score or that set score. Was there any questions out of that? What overriding is, other than the dog? Okay, I'm going to go back and share again. If I ever want to prevent something from being overwritten, and we've seen this a little bit in Java, we've seen it more in C++, but being able to lock down a value or a method, and here we can lock down this one with the word final. Just information to tuck away. Okay, section 10.4 has something called a protected member. So instead of a variable being private or public, it can now be protected. And if it's protected, my subclass can now use it. Say that again. If it's protected, my subclass can now use it. Can also be used by methods in the same package, but we're worried more about right now the subclass. Okay, so instead of the access specifier being private or public, it's now going to be one that's called protected. Why do we want to use it? Then I don't have to use all of those sets and gets, is the big reason why. So yeah, here's a nice little table for access specifiers. Okay, if it's public, protected, and private. Okay, accessible to the subclass in the same package. Public is, protected is, private is not. Accessible to other classes, yes, yes, and no. Slight differences down here. If I say protected, it's good in the same package, but not outside the package. Just a slight difference. So it's not a bad one to have protected. That was section 10.4, and that was an example of graded activity. I don't know that we really needed code listings from it, but hopefully you got the idea of what's going on. All right, I believe the last section we're covering today is maybe 10.6 yet. Yes, 10.5 and 10.6. 10.5, this is the one that's going to be the most important to you because this is going to be your next program, and I'm going to post that in a little bit. I made some changes to what I had before just because I'd like something, you know, I like when I can tell you to write a program on something of your interest because the aggregations were pretty cool, a lot of them. All right, so, oh boy, chains of inheritance. I have a class. This one at the very top listed is called object. An object is actually section 10.6. Object is the class. It's the one we start with. There's not much in object. Does anybody know something that could be in object?
Two-string?
Yes, there is a two-string that is tucked away in object. Right, that, excuse me, that's one. Another one,
Equals was one.
yeah, and we've talked about this briefly before, I'm pretty sure. But we mentioned this class. It's called object. It is the super deduper class. Okay, everything starts and gets inherited from that. So we were talking about classes a little while ago, and when I just talk about a class, there's actually a parent-child relationship, a superclass subclass. Here is an example of chains of inheritance. This is section 10.5. I have object, and we know right away I'm going to overwrite the two-string. Okay, overwrite the two-string. Now, there was a question while you were working on what you were just working with in rectangle and cube. And if there was a two-string in rectangle, how could I use that in a two-string in cube? And you really can't, because you would need to instantiate an object like we did in aggregation to be able to call that guy's two-string.
Yeah, I was wondering that, and I just used super dot two-string. It compiled, but I didn't test it out in the driver, so
Okay.
that wouldn't work.
That might. So if it does, you can post it, put something on a discussion board to let everybody know.
Yeah, I think the
Right.
super worked with the
Okay.
tested out. Yeah.
Super dot two-string.
Yep.
Okay, good. So now I have something way down there at the bottom, pass, fail exam. That puppy is loaded with methods. It takes the methods from pass, fail activity. It takes the methods from graded activity. And so I inherit it. And it's something where I can start with something small and then build on it. And when you see the program, you'll get that idea of the building on it. Okay. Sometimes you're going to see things depicted with UML charts this way. Remember earlier we had graded activity that gave me that letter grade, and we started working with final exam and how it was a subclass. And then we could have talked about, like we're doing in this chapter or this section, pass fail activity inherits from graded activity, and we have pass fail exam. So instead of a score, and we call the set score of A, B, C, D, and F, pass fail is going to give me a grade of P and F. So I'm not really going to dig into that and talk about it too much, but I think conceptually you get the idea. Plus, that's what you're going to be working on with your next program. So the last thing I want to do today, and I want to get you to do a little more typing, I'm going to go to, I'm talking off to the side because I have it written down somewhere. There it is. I'm going to go to page 700 in my hymnal. Page 700. I'm going to stop sharing here. I come to here and I'm looking at number 10. Number 10 is a ship, a cruise ship, and a cargo ship. Okay. Design a ship class that has the following members. So I'm going to do this class. A field for the name of the ship, a field, a constructor with accessors, mutators, and a two-string. Hopefully by now I say that and you're going, yeah, I can do that. And I can name that note in 5 or song in 5 notes. You know, nothing in there is a surprise. Design a cruise ship that extends ship. Design a cargo ship that extends ship. Okay, so here's the UML charts for each of these. These two are subclasses of ship. Now, what do I want you to do? Demonstrate how all of this works And has, but it wants you to do an array. I don't need you to do an array. I just want you to do with one ship. Assign a couple of objects. And again, I don't want you to do array elements, just do something simple. But let's see if instead of building on what you did with rectangle and cube, you can take this and run with it and put it together. So I'm going to put you in groups of maybe 5 or something, so that you can get in the group and say, well, why don't you do this one, you do this one, you do this one, and we'll put it all together. So I want you to do this more as a group project instead of 1, 1, 1, 1. And as you finish things, you can share them however you like to share them on your discussion board, and you can put them all together to see if they work or whatever. Okay, so I'm going to recreate different breakout rooms, recreate, and there's going to be, I'm going to make it 3 rooms for everybody. And like I said, you're going to divide and conquer this, do it as a group. You have 15 minutes, possible you can pull this off. Because I like group work. All rooms are open. I will see you next week.